So let's start. And so this is the diagram that if you remember from the previous class. So we had the virtual address. So virtual address was generated by the CPU, right? And then first of all, we look up in the TLB, right? We first find its corresponding physical address, right? We want to find for that particular page number, we want to find its corresponding frame number so that we can get the physical address. So first we do TLB lookup, and either there will be two cases. Either it is going to be hit in TLB or it is going to be a miss in TLB. If it is a hit in TLB, in that case, you are going to get the frame number, right, from that page table entry in TLB, and then you can get the particular physical address, and then you can directly go to the main memory to get the actual data or the instruction. If it is a miss in TLB, in that case, we have to do page table lookup. Basically, we want address translation. We want to do address translation, right, from virtual address to physical address. And if it is a miss in TLB, that means the entry is not present in TLB. Definitely, you have to look in the page table. So if we do page table lookup, in that case, there are again two cases, whether it is a valid page or it is an invalid page. If it is an invalid, it is a valid page, in that case, you will be getting the frame number, and again, you will be getting the physical address, and then you go to the main memory to get the data. But if it is an invalid page, that means invalid entry is there for that. So in that case, page fault will be generated, page fault interrupt will be generated, trap to operating system, and then operating system will do what? It will select the victim page, right? That means page replacement algorithm will come into the picture. So now from here on, everything is being handled by operating system. Operating system will select the victim page, and it will check whether the page is dirty or not. So for that, we have a dirty bit, right? That means page is modified or not. If it is modified, you have to write back first to the secondary memory, and then you have to load or read the faulted page. You have to move that into the main memory and update the page table and TLB entries, so that the CPU, when again it is going to restart the instruction, it will get to know that now we have the physical address for that particular virtual address. Okay, that means the address translation can be done. If it is not a dirty page, directly you can read the faulted page. That means you can load the page uh, from the secondary memory to the main memory, and you can easily replace it. And then again, the same thing, update the page table and TLB entries, and then restart the instruction, and you will be getting the physical address, and you go to the main memory to get the data. So this is the entire flow. Whatever you have in red, that is all hardware based. Whatever you have in this black, that is being handled by the operating system. Okay, right? And your page table also presents in the main memory. Okay, you know this, right? So now we have one question based on this. Now carefully read this question. And this question was asked in GATE CS 2020. So it was asked in GATE CS 2020, and now we are going to read this. So let's read it out. Consider a paging system that uses a one-level page table residing in main memory. Okay, TLB for address translation. So we are considering a paging system. We have a one level, single level page table, flat level page table, and one TLB for address translation also we have. Each main memory access takes 100 nanosecond. Okay, and TLB lookups takes 20 nanosecond. So let me write here. Okay, let me just write here that main memory access time, takes 100 nanosecond, and TLB access time or lookup takes 20 nanosecond. That is given in the question, right? Now, each page transfer to or from the disk takes 5,000 nanosecond. So if you, let's say, if you want to load the page from the secondary memory to the main memory, in that case, it will take 5,000 nanosecond. Or if you want, if let's say the page is dirty, right, and that is modified. So in that case, you are going to write that page, the updated page, in the secondary memory. That means from main memory to secondary memory, you are going to write that page. So you are going to basically do page transfer kind of. So basically it will also take 5,000 nanosecond. So if page transfer to or from the disk takes 5,000 nanosecond, that is given in the question. Assume that TLB hit ratio is 95%. TLB hit ratio is given to us, that is 95%. Fine. And page fault rate is also given to us. Page fault rate is also given to us, which is 10%. Right? Now, assume that 20% of the total page faults, out of total page faults, 20% of the total page faults, a dirty page has to be written back to disk before the required pages read from the disk. Are you getting this point? That means out of the total page faults, just for 20%, a dirty page has to be written back to the disk. That means there is, you have to, that is a dirty page or that is a modified page. So you have to write it back to the secondary memory. And it is going to happen just for the 20% of the page faults. Okay. TLB access time is, TLB update time is negligible. And the average memory access time in nanoseconds rounded off to 1 decimal place, you have to find out. So let me add one slide. Let's try to solve this question carefully. We know the flow, right? We know the flow that first of all, we have the virtual address. This virtual address, we will first look up in the TLB. Yes or no? We will first do TLB lookup. Now there are two cases. Either it is a hit or it is a miss. Either it is a hit or it is a miss. If it is a hit, then what to do? You will be getting the, getting the physical address, right? Address translation will be done, and then directly you can move to the main memory. Directly you can move to the main memory to get the data. Yes or no? Correct. But if it is a TLB miss, if it is a TLB miss, then definitely you will go to the page table lookup. You will do the page table lookup. You will do the page table lookup. Yes or no? So if it is a TLB miss, you will do what? Page table lookup. Now in page table also, again, you have two cases. Either it is a hit, or it is a miss, or it is a miss. When I say hit or miss, that means the valid, you get the valid page entry or not. If you get the valid page entry, right? If it is valid, then it is a hit. If it is not, then it is a miss. Okay. So that is what it is saying. Or yeah, that is how you can write, or valid in terms of invalid or valid also you can write. So let me write in that terms only, just for it, So here it is valid, and here it is invalid entry. That means you are not trying to find its corresponding entry in the page table. Okay, then what to do? If it is valid, definitely you got the translation done, and you can move to the main memory to get the data. Is it clear? You can move to the main memory to get the data. But if it is invalid, that means page fault will be generated, right? If it is invalid, that means it is a page fault. If it is invalid, that means it is a page fault. So I'm explaining the entire flow, and then I will be solving this question, okay? So if it is invalid, then it is a page fault. Trap will be generated to operating system. Then according to the question, for 20% of the page faults, a dirty page has to be written back. So if it is a page fault, out of total page faults, for 20%, we are going to check whether it is a dirty page or not. Right? Whether it is a dirty page or not. If it is a dirty page, in that case, what we are going to do? We are going to basically, we can represent it like this. But if it is a dirty page, then you are going to say, yes, it is a dirty page. Then select that page, or dirty page or victim page, you can say. So for that dirty page, you are going to write to the secondary memory. You are going to write that to the secondary memory. Are you getting it? You are going to write that to the secondary memory if it is a dirty page. Fine. and then you are going to load, the required page, because it was a page fault, right? You need that page. So you are going to load that required page, and you are going to load it to the main memory. So you are going to load it to the main memory. So main memory I've written here also, and just I've written here also, just for your understanding that, okay, we are loading it back. So we can write also that loading it in main memory, right? And then obviously when you are loading it in the main memory, you have to update the page table and all, everything, TLB entries, right? So page fault, yes, it was a page fault. And if it is a page fault, that you have to check, okay? You don't have to write it also, right? But if it is not a dirty page, in that case, what? In that case, simply you can just go to the secondary memory, and then it will be loaded into the main memory. So this is the flow of this question basically. Okay. So based on it, you can solve this question. So let's solve this now. So first of all, we know, TLB lookup will be done. Either it is a hit or it is a miss. Let's say that it is a hit in TLB. If it is a TLB, what is the hit rate? TLB hit rate is 95% or 0.95, I can say. 0.95, that is the TLB hit rate. So if that is the TLB hit rate, that means we got the entry in the TLB. If I got the entry in the TLB, then TLB access time is 20 nanosecond. So can I say it is 20 nanosecond plus, then I have done the address translation from virtual address to physical address because I got the entry in the TLB, right? Translation is done. Then we just have to directly access the data from the main memory. So in order to access the data, we need 100 nanoseconds. So can I write 100 here? So this is the scenario when there is a TLB hit. Is it clear so far? Now, if it is a TLB miss, so if hit rate is 0.95, definitely 0.05 is going to be the miss rate, TLB miss rate, right? Now, if it is a TLB miss, if it is a TLB miss, what to do? Then we have to check in the page table if it is a TLB miss. So if it is a TLB miss, you have to check into the page table, and in the page table itself, you have the page fault rate given, that is 10%. Page fault rate is given. So if it is a TLB hit, a TLB miss, in that case, either you are going to get that in the page table or not. If you get that in the page table, so if page fault rate is 10%, so page hit rate in page table will be 90%. So can I say it is going to be 0.9? That means we got that particular page table entry from the page table, right? So if there is no page fault, you can say, so if there is a no page fault, so 0.9, that means there is no page fault. If there is no page fault, then I can say that TLB access time, definitely you had to access, plus the page table lookup time, that is again 100 nanosecond, because page table also resides in the main memory, and there is only one level of page table, so just 100, plus you can directly get the data. Is it clear so far? This is how you are going to do it. So that was the case when there is no page fault. Now, if there is a page fault, so page fault rate is 10%, that means 0.1. If there is a page fault, then if you see in the question, it is given that for 20% of the page faults, you are going to perform this dirty page task, right? You have to perform for 20%. So if there is a page fault, for 20%, you are going to perform that dirty page task. That means for 80%, you are not going to perform that task. You are just going to do what? in that case, if there is, if for 80%, you are not going to write the dirty page back to the secondary memory. That means you are going to access the TLB first, then you are going to access the this page table, then page fault was generated, right? Because 80% for 80% also page fault was generated. So if page fault was generated, you are going to directly load that data from the secondary memory to main memory. So just let me write it, and that will take how much? Or should I write it in the next line? That would be better, I think. Yeah. Just okay. Let me write it here. So plus 5,000, because you are going to load that page, required page, from the secondary memory to the main memory, and then you are going to access the data. Then you are going to access the data. Is it fine? Now I'm writing here the rest of the expression. So for 80%, we are going to go to the TLB. We are doing the page table lookup. We are loading it from the secondary memory to main memory, right? And then finally accessing the data. Fine. But for 20%, what we are going to do? For 20%, as it is mentioned, for 20% of the total page faults, a dirty page has to be written back to disk before the required pages read from the disk. So first you have to write it back to the secondary memory. So for 20%, first TLB access, then page table lookup. Then first you are going to write a dirty page. That will again take 5,000 nanoseconds, because if you are reading it or writing it to the secondary memory, it takes 5,000 nanoseconds. And then you are going to load the required page also, so 5,000 nanoseconds. And then finally, when you are loading the required page from the secondary memory to the main memory, then you can finally directly access the data that is required. Is this clear? So here I can just close this bracket, so yellow closing bracket, and then finally I can close this, the orange one. So this is going to be the the values after substituting according to the question. So if you solve this, you will be getting 155.0 nanoseconds as the answer. Now let me write it what means what here. Carefully see. This indicate there is a TLB hit. Fine. This indicate that TLB lookup. This indicate the direct data that you are getting from the main memory. Clear? This indicate TLB miss. If there is a TLB miss, in that case, what to do? So first you are going to check whether there is a page fault or not, right? Yeah, so whether there is a page fault or not, because 10% is the page fault, that means 0.1. So for 0.1, there is you have to do certain task, right? I mean, there is page fault 0.1%. That means page fault rate is 0.1. That means for 0.9, there is no page fault. Simple. So I can write here that there is no page fault here. Let me use another color. Here I can say no page fault. If there is no page fault, definitely TLB lookup, page table lookup, and then the data. Because there is no page fault, you will be getting the entry directly from the page table, and you will be getting the physical address. You can get the data from the main memory. But if there is a page fault, so this is for page fault. Yes, there is a page fault. If there is a page fault, then for 80%, you have to do certain task. That means you don't have to do any dirty read kind of thing, because you, out of total page faults, just for 20% you have to do this. A dirty page has to be written back to disk before the required pages read from the disk. But for 80% you don't have to do. So this is what, let me write here. This indicates what? This indicates that you are writing right back dirty page. write back the dirty page. And this is what? This is reading, or you can say loading a required page from secondary memory and writing back dirty page to secondary memory. And this is for the final data, because now you have that data, you have that page in the main memory, so definitely you can access it. So I hope it is clear what we are doing here, right? So this here secondary memory to main memory is nothing but this thing. Okay, this thing only. That means reading or loading the required page from the secondary memory to the main memory. So I hope now it is clear. And if you solve this, you will be getting 155 nanosecond as the final answer. And we have the solution also given here. So you can just verify from it. So 0.95 into 20 plus 100, 0.95 into 20 plus 100, yes. Then 0.5 of 0.9 into 20 plus 100 plus 100. 0.5 into 0.9 of 20 plus 100 plus 100, that is correct. Then 0.10 of 0.8, then 20, 100, 5,000, 100. 0.1 of 0.8, 20,000, 20, 100, 5,000, 100. That is also correct. Then 0.20 for 20% of the page faults. 0.20, 0.2 basically. 20 plus 100, 20 plus 100, then 2 times 5,000, 5,000 plus 100. So that is what we are getting. Yes, this is correct. This is absolutely correct. So 155 nanosecond is the answer. So you can see the question was little tricky. I can definitely say this, that it is not a very easy question. It is a little hard question. But if you have that entire flow clear in your mind, then after, first we have to do TLB lookup, then if, then maybe page table. If there is a miss, then accordingly, if there's a page fault, then what to do, dirty page, then what to do. So as per the question, everything is given in the question. As per the question only, you have to solve this. Okay, so everything is given in the question, and this is the flow as per the question that is given, and then you can directly solve this question. So it was a little hard question, I would say, but yes, if the flow is clear in your mind, definitely you can solve it correctly. Okay, so that is that was a really good question from Gate previous year. Okay, now